Let's do a problem from section 8-4 where we're doing a hypothesis test for a mean and sigma is known. You should always check the requirements before doing a hypothesis test to make sure that you have all the requirements satisfied. We want to assume that we have a sample that is simple and random. We want to make sure that sigma is in fact known for our problem. And we want one of these two conditions, or both, to be satisfied: that the population is normally distributed, or we have a large enough sample of 30 or more. This is the formula for our test statistic. We're actually not going to use this formula because we're just going to rely on our calculator. But should you need that formula, here it goes. So our first step is to identify our claim. Now if we just read through this statement, the problem, we can identify the claim. So if we take a look at it carefully, we see that tests for older baseballs, when dropped 22 feet from the concrete surface, they bounce an average of 238.9 centimeters. Now we tested 50 new baseballs. They bounced the height that had a mean of 234.9 centimeters. Here is where we assume the standard deviation of bounce heights of all new baseballs is 4.3 centimeters. They want us to use a 0.01 significance level to test the claim. Here we go, test the claim that the new baseballs have a bounce height with a mean different from 238.9 centimeters. So that is going to be our claim right there. The new baseballs have bounce heights with a mean different from 238.9 centimeters. Now we want to state that in mathematical terms, and so in mathematical terms the mean for the population is mu, and it's different from um, 238.9, and the units aren't really necessary here, but we'll just put them on anyways. 238.9 centimeters. Now the opposite of this claim will essentially be the same thing, except we will have an equal sign, and between the null and alternative hypothesis, the one with the equal sign has a condition of equality and should be the null hypothesis, and the other one is going to be the alternative. And just for good measure, we should actually label it as the claim. I'll get there. Alright, so next step is we want to identify our alpha. And our significance level is given to us here at 0.01. The next step, we want to identify all the possible statistics that we'll need. Looks like we'll need x bar, mu, sigma, and n. So x bar x bar was given to us, and that was equal to the 50 new baseballs. That's 234.9 centimeters. Our standard deviation was also given to us. Actually, we don't need the standard deviation. We actually need to provide the population standard deviation since we're assuming that. So our sigma in this case is going to be 4.3 centimeters. And then the number of baseballs that we're looking at, that we're testing, n is equal to 50. So instead of using this formula to get our test statistic, what we're going to do is we're going to just punch it in our calculators. So let's get our calculators out and punch some values in. We're going to go to Stat, Test, and this is the case where we're doing a hypothesis test on a z distribution with only one variable. So we're going to look at the z-test. We have statistics. Our mu is 238.9. Our sigma is 4.3. Our x bar is 234.9. We have 50 baseballs that we're testing. And this option is our alternative hypothesis, which is selected. And so we just need to have it calculate for us. So let's see if we can, some of these. We have our values. What we really want is, depending on what we're going for, we could have a test statistic. We can report our test statistic, or we can find our p-value. In this case, we have both these pieces of information here. So our test statistic is a z-value. So that's z equals, that's a negative 6.577, so let's call it 7.8. They usually want it rounded up to 2 decimal places. Our p-value, if needed, is going to be 4.8. 0 times 10 to the negative 11th power, which is going to be a really small number. So if we were using a the traditional method, which I think this problem is going to ask us to do, we would draw our graph and we would need to find some of our points, critical values. So let's go back to the calculator real quick and just quickly run through the test again. And all our values are still there. And then this time I'm going to ask the calculator to draw the graph for me so I can have a nice bell-shaped curve. So it's going to give me my z-value, and it says the p-value is actually 0, but it's not exactly 0. It's a really small number. So let's see. Let's take a snippet of this. And in doing so, what we're going to be interested in is, let's see if I can paste it on here. What we're going to be interested in is identifying our critical values. So at the 0.01 level, our critical values would go, let's see, it would go somewhere over here, probably, or maybe a little bit more. But we can find them. This is a two-tail test. So we know that we're going to shade in the values over here in our tail, a two-tail, because of the alternative hypothesis. And our test statistic is negative 6.57, so it's going to be probably in the critical region, but we should double check and find our critical values here. So we're going to get two critical values. One of them is going to be a negative, the other one's going to be the exact same but the positive. And the way we can do that is we can take our calculators and do the second and distribution. So we're doing the inverse norm. And we're looking at the area to the left. So if we focus on this negative one, we have our alpha is 0.01. But because it's a two-tailed, it gets cut in half. So let's divide that by 2. So an inverse norm will give us a negative 2.575 or 576. Again, usually they want this in 2 decimal places, so let's call it negative 2.58. So negative 2.58, 2.58, and so clearly your test statistic, your Z, is going to be in the critical region. So that's enough for us to make a conclusion. Since the test statistic is in the critical region, and if you want to, kind of specify that negative 6.58 is less than negative 2.58, we can say that we reject the null hypothesis. So in rejecting the null hypothesis, we come up with a table, and the table that we have will will run us through a flow chart, and it's going to ask us if the original claim has a condition of equality, and we say no, and then it's going to ask us if we rejected the null hypothesis, and we say yes. So after going through the flowchart, you can follow the flowchart and see that the phrase that you're going to use is that the sample data support the claim that, and then the actual claim was this first statement that we came up with. So we can just copy and paste that, and this is the end of our hypothesis test. So let's check our answer. This is the actual problem that we were looking at. It's asking us what are the null and alternative hypotheses. So the null hypothesis has the equal sign, and the alternative has the not equal sign, so I think that would be A. What is the value of our test statistic? Our test statistic is negative 6.58. Our critical value, we found our critical value in our calculator, which is, there's 2 of them since it is a two-tail, so it's a negative 2.58 and then comma positive 2.58. And then in the end we ended up rejecting the null hypothesis, and we say there is sufficient evidence to support the claim that the baseballs are different. So let's just check that, and we got it correct. So this is an example where we were doing a hypothesis test for a mean, and the the population standard deviation sigma was known.